Welcome back, everybody. So in this video today, we're going to be talking about Ohm's law and how that applies to electricity and its circuits. Right? So let's jump right into it. Ohm's law. Right? The long, wordy version is the resistance in a circuit is the ratio between the electric potential difference in that circuit, voltage, and the current flowing through that circuit. For our purposes, basically, we're just going to be looking at this as we have a constant voltage, constant electric potential difference, and that, along with the resistance, determines how much current is in the circuit. So we don't really deal with a variable voltage source for our purposes here. Not even really a variable resistance either, but we can always say, hey, let me take out a resistor, put in a new resistor. Okay, so anyways, the way you'll see this equation or this law is in a couple ways, right? We have R equals V divided by I. Resistance equals electric potential difference divided by current. Okay. Now, you may have also seen this same equation and some other time in your life looking like this. V equals IR. Electric potential difference equals current times resistance. Okay. This equation is going to be very important over the next few topics here, because not only are we going to talk about it just as a standalone thing, but we're going to eventually apply it to circuits that have more than one resistor in it. For this video, though, we're going to stick with a circuit that has just one resistor in it. Right? Now, before we even get into kind of solving those, let's talk about how you might actually see a question like this being proposed. Okay? There might be some sort of diagram on the question that tells you different things about the circuit. Its voltage, where that voltage is coming from, its resistance, where that resistance is coming from, how these different things are measured, right? And that's called a schematic. Right? So let's talk about different circuit symbols that would go into a schematic. First one we're going to talk about is important for any circuit to work properly, and that is a source. Okay, so where is that electric power coming from, right? Remember, we're sticking with direct current, DC, so we're not going to talk about, oh, it's coming from the outlet or anything like that. We're going to talk about something that gives direct current. So for our purposes, we'll have one of these two things. Okay? This is called a cell, where it's one long line and one small line, or a battery, which is multiple cells. Okay, that's actually where the term battery comes from. Back in the 1800s, before they had, double A's or stuff like that, they had to have these giant tubes of an acid and an electrolyte, and in order to get more current out of this, or more voltage, they had to have a bunch of these. And they said it looked like a battery of cannons, an artillery battery. So that's kind of why we have more than one cell making up the picture for a battery. Okay? Now, that's how you get your source, right? A wire, just a simple wire, okay? Now we have a symbol that looks like this, and that is going to be our resistor, okay? So our symbol for resistor is kind of a sawtooth, kind of like kind of picture, okay? That could be a light bulb, that could be just a standard resistor, okay? Speaking of light bulbs that act as resistors, this is another symbol that you might see, right? So it's kind of a curly Q encompassed in a circle. That's called a lamp, basically just a light bulb, right? Light bulbs act like resistors for our purposes, especially, right? When we talk about real life light bulbs, especially incandescent light bulbs, like the old-fashioned kind of light bulbs, they're not the best for this, simply because, well, as the temperature heats up, that changes the resistance and it changes the whole aspect of it. But that doesn't quite matter for what we're talking about here. Now, you might need a device that helps you measure either the current or the voltage. And those have their own symbols that look like this. Okay? So this line just represents the wire, right? And then the circle with the letter in it, A for ammeter, V for voltmeter, right? So an ammeter is a device that measures current. Voltmeter is a device that measures voltage or electric potential difference. they're not necessary for understanding the problem. They're just extra little bits. If we were to build a real life circuit, you would need those to help you measure those values. But for a picture just in a problem on a piece of paper, you don't really need those. Anywho, that is pretty much all we need. You could run it into a couple other symbols, maybe one that looks like this, right? So that's a switch, but again, a switch is not necessary. The important ones are the source, whether that be the cell or the battery, and you need a resistor. Okay, so what would that look like? Well, here is my example of a perfectly fine circuit. Here's our source, connected by a wire to a resistor, connected right back to the source. Okay, my habit is just to draw a battery. You can draw just a cell, it doesn't matter. Another thing that doesn't matter is how that cell or battery is oriented. So obviously this one is upside down compared to that one. All fine, all good. As long as you have a long line and a short line, then we are good to go. Okay, now, how might you take a picture like this and turn it into a problem? Well, let's figure that out. Let's say this battery that I drew is a 12-volt battery. And let's say that resistor is, let's make my numbers a little easier, we'll say that's 24 ohms. Okay, so we have a 12-volt battery and a 24 ohm resistor. I might ask you, what is the current in this circuit? All right, well, let's use our equation. R equals V over I. Our R is our 24 ohms. Let's scoot that over. 24 ohms. Our V is our 12 volts. And our I is the unknown. Well, do a little math. We say that I equals 12 volts over 24 ohms. Which, quick foray into your calculator or just in your brain, tells you that is 1/2 amps. There you go. Pretty simple. Okay. In terms of Ohm's law with just a simple circuit like this, with just one resistor, that's all there really is to it. In another video, we're going to be looking at what happens if you have more than one resistor in that circuit. There are multiple ways you can hook up resistors into circuits, either all in one loop called a series circuit, or all in separate loops called a parallel circuit. We're going to spend time on each of those in their own video on another time. But for now, just know that you have your Ohm's law equation, R equals V over I. All the things that you learned about in the previous topics for electric potential difference, current, and resistance all still apply. This just kind of lumps them all together and more generalizes things and puts it into something that's applicable to relate the three. And that's pretty much all there is to it. You can check your reference tables for those symbols if you don't remember, and check the video, check the notes that are posted, and you should be good to go. Till next time.